Greetings everybody, and welcome to our next video on cross products. So what we're asked to do in this problem is to compute the area of a triangle given 3 points in three-dimensional space. And so basically the idea with that is that we have our point A, and then over here we have our point B, and then somewhere else we have our point C. Well, if we imagine that we take the vector from A to B, and then we also take the vector from A to C, and if those two vectors really form the sides of our triangle, so we have our third side between C and B, well, if we imagine drawing the parallelogram, then basically what we have is that the area of our triangle ABC is going to be equal to half of the area of the parallelogram. And so how do we get the area of that parallelogram? Well, remember that's one of our properties of our cross product. That was actually how we came up with the formula for the cross product, was the length. So this will be half. So this will be equal to half of the length of the cross product of our two vectors from A to B and from A over to C that form the sides of our triangle. And so in this case, all we really need to do is to come up with those two vectors. So for our vector from A to B, we're really just going to have the endpoint minus the beginning point. So 0 minus 2, and then 1 minus a negative 3, and finally 2 minus 4. And so we end up with our vector from A to B being negative 2, 4, and negative 2. If we do the same thing for our vector from A to C, ending point minus beginning point, we have A minus 1 minus 2. We have a 2 minus a negative 3, and we have a 0 minus 4. And so this will give us a vector negative 3, 5, and negative 4. Taking the cross product of those two vectors, we are then going to have, so remember this, kind of using our 3 by 3 determinant to help us remember what our formulas were. And so we had a negative 2, a 4, and a negative 2. And then a negative 3, a 5, and a negative 4. And so what we then have for our cross product will be equal to our first 2 by 2 determinant, going to be 4, negative 2, 5, negative 4. Our second determinant, getting rid of the first row, getting rid of the second column, we have a negative 2, a negative 2, a negative 3, and a negative 4. And then finally, our third determinant looks like a negative 2, a 4, a negative 3, and a 5. And so what this gives us then as a cross product vector, we have a negative 16 minus a negative 10, so plus 10. We have a negative of a positive 8 minus a 6. And then finally, for our third determinant, we have a negative 10 minus a negative 12. And so this gives us a cross product of negative 6, negative 2, and 2. So that for the length of that cross product, we are going to have the square root of 36 plus 4 plus 4. So we have the square root of 44, which looks like 2 times the square root of 11. The area of the triangle ABC then is going to be half of the length of this cross product. And so we have 1/2 of 2 root 11, or just an area of the square root of 11. So I hope you've enjoyed this video, kind of seeing how these problems work, and I will see you guys in the next problem. Take care.